Hi, I'm Amy Bodette from the Altese Store. Thank you for watching the first of our video series on designing an off-grid solar system. This first video is appropriately called Step 1, Loads List. Figuring out how much power you need is a critical step that many people try to skip. Designing a solar system without knowing your loads is like being asked how much gas do I need to drive, without knowing what type of vehicle or how far you're driving. Let's start at the beginning. Here's a basic schematic of a typical off-grid system. You'll notice there's a generator in the drawing. That is for instances when there's not enough sun to provide the power needed, generally winter, and if you have an occasional load that requires more power than your system can provide. For instance, if you needed to use a welder for a project, it may not make sense to design the whole system to be able to accommodate a tool that is only used once a year. So having a generator available for occasional use makes good sense. Keep this option in mind when designing your system. This video series will cover the major steps of designing an off-grid system. Let's start with Step 1, Analyzing your load. So let's go over the steps to determine the amount of power you need. Let's start with a loads analysis. Unlike a grid-tied system where you can just base a system on how much power you want to offset and then get the rest from the grid, an off-grid system needs to provide all of your power. With an off-grid system, you need to take a good look at what you are powering and how long you need to power it. Going off-grid often takes changes to your lifestyle. It's not just as simple as saying, I'm tired of paying the electric company, I'm taking my whole house off-grid, I'm going to stick it to the man. You have to figure worst-case scenarios. Wintertime with little to no sun for days. Unless you're in a climate that has long sunny days all year round, or this is for a seasonal house, most people who are doing a year-round off-grid system will have a generator available to pitch in the winter. I read a quote from an off-gridder who said, if it's going to be a sunny day, I can cook waffles for breakfast. If it's cloudy, I have a bowl of cereal. When designing the system, you can't just say it's an average-size system. No such thing. You also can't base it on square footage of a house or cabin. One cabin may have air conditioning, an electric stove, water heater, electric washer and dryer, a fridge and freezer, and the other may have LED lights and a laptop. Which one is average? Who's to say? Do you think the same system will work for both cabins, even though they are both the same physical size? No. You need to make a complete list of every electrical device you'll be using, how much power it uses, and how long each day it'll be on. Don't forget anything. All UL listed equipment will have power label on it. Since volts times amps equals watts, you should be able to get all the information you need off the labels. Here's some examples from just walking around my house. You can see some do list the watts, and some list a voltage range. Some have the amps, and some list the DC voltage and amps used from a power block that's converting the AC voltage to DC to charge the onboard battery. If the label only lists the volts and amps, but not the watts, you can multiply the volts times amps to get watts. Once you have watts, you then multiply the watts times hours a day that it's on, and you get the watt hours a day. This is not perfect, as the listing may just have the startup current and not the continuous power, but it is a starting point. If the voltage is listed in DC instead of AC, you would still multiply the DC volts by the amps to get the watts. If the voltage listed is a range, like 100 to 240 volts, you would use the voltage that is used in your area, for instance 120 volts for North American outlets. Some loads, like a refrigerator or pump or furnace fan, are not on continuously and have a high surge when it turns on, making it difficult to determine how much accumulated power, or watt hours, it uses throughout the day. If it is ENERGY STAR rated, you can find the ENERGY STAR label, either on the appliance itself or on the ENERGY STAR website. If it is not ENERGY STAR rated and you're looking to power it with solar, it may be worth it to replace it with an ENERGY STAR fridge. The reduced amount of power that an ENERGY STAR appliance uses may pay for itself when you look at how much it would cost to power it with solar. The ENERGY STAR label will tell you the average annual kilowatt hours used. From there, you can simply divide it by the number of days in the year, 365, to see how many watt-hours it uses in a day. In this example, 383 kilowatt-hours a year divided by 365 days in a year equals 1.049 kilowatt-hours a day. You can multiply that by 1,000 to determine how many watt-hours a day, as a kilowatt is 1,000 watts. A more accurate way of determining the power consumption is to measure it with a device like a kilowatt meter. You plug the meter into the outlet and then plug your appliance into the meter. It will show you an instantaneous wattage, volts, amps, and accumulated watt-hours. It also shows how long the unit was measuring, so you can divide the watt-hours by hours to see how many watts it's drawing on average. Multiply that by 24 hours, and you have how much it actually used in a day. For example, if the kilowatt says it used 1260 watt-hours over 30 hours, that averages 42 watts. 42 watts times 24 hours in a day equals 1,008 watt-hours in a day. Taking it one step further, 1,008 watt-hours divided by 1,000 equals 1.008 kilowatt-hours. All right, now that we know how much power each device is using, what do we do with that info? Using a load calculator can help you create the loads list. This calculator is available on ALTI's website. To use it, you enter the appliance name, quantity, and how many watts it is in AC or DC. You'll know if it's AC if it plugs into a wall outlet. If it's DC, it runs off a battery, like a cell phone car charger. On at the same time indicates that the system needs to be big enough to power those devices simultaneously. For example, you have no control over when your fridge compressor will turn on, or when your well pump will, but you can control when you turn on a light. So if there's a chance that multiple devices may be on at once, you must select on at the same time. That will help you determine how big of an inverter you need to handle that power if they all turn on at once. Some devices also have a high momentary surge, like a fridge or motor. It can use 2 to 4 times as much power for a few seconds when it first turns on. You need to keep track of that as well, because if your inverter cannot handle that surge, the device may not be able to turn on, or you could damage the inverter. You'll need to enter how many hours a day a device will be on. If it's less than an hour, do the decimal equivalent. For instance, a half hour is 0.5. Whether you're using the calculator or doing the list by hand, all of the watt hours get added up to show the total amount of power you need to generate for that day. That's it for the first video in this series of designing an off-grid PV system. You can go to our website to use our loads list calculator to calculate your own loads. Watch the next videos in this series for how to size a battery bank and solar array using the numbers we came up with from our loads list. Also watch more of our various video series on our website. We've got a team of highly trained technical sales reps available to help you plan your system. Give us a call. Thanks so much.